we come up to, oh my gosh, our final panel of the day, our third and final panel, and that will be hosted by Keely Griffith. She's the Director of Industry Education for the Association of Unmanned Vehicles International. AUVSI, very active in the development of so much going on with drones and beyond. We're thankful to have them participating. Keely, thanks for joining the World Safety Summit 2021 and look forward to hearing from your panel.
Thanks, Charlie, and I'll invite all of them to join us now. Good morning or afternoon, depending on where you're coming from. My name is Keely Griffith. As Charlie mentioned, I am the Director of Industry Education at AUVSI. AUVSI is a nonprofit association devoted exclusively to advancing unmanned and autonomous systems and robotics. Our members really represent the full community, so from designers to manufacturers, service providers to end users, researchers to instructors, and our work spans all domains, air, ground, and maritime. Today, I'm joined by a great group of stakeholders in the robotics and autonomous vehicle industry to discuss use cases of these systems that promote safety and automation in various verticals. The impact that these technologies have is really being realized in integration into construction and utility sites, warehousing, and even inspection and surveying focused industries is really becoming more mainstream. One recent example that highlights this hit the news last week. Boston Dynamics and IBM have partnered to deliver a flexible and responsive option to providing data solutions that are going to improve worker safety, enhance productivity, and improve field ops with organizations like National Grid. So to launch us into this great conversation, I'm going to ask each of our panelists to briefly introduce themselves. And let's kick things off with Adam.
Thanks, Keely. Hi, everyone. I'm Adam Schrab. I lead marketing for NVIDIA's effort in applying AI and computer vision to smart infrastructure, to smart spaces. We've spent the last 7+ years building up an ecosystem of applications and development ecosystem. We're active in literally kind of dozens of sectors, and safety and efficiency is really our goal. So it's perfectly aligned to I think this panel. I'm excited to be here. Awesome,
thank you. Grant.
Thank you very much, Keely. My name is Grant Harris. I run business development for Axon Technologies. We're a spin out of the GRASP Robotics Lab at the University of Pennsylvania. And we specialize in making autonomous robots that remove the human element from dangerous situations. So we specialize in getting the robots into impossible to reach places with no outside inputs like GPS or other configurable tools. And this pulls people out of dangerous environments, repetitive tasks, and just keeps them safe. We're platform agnostic, and we work with aerial units as well as ground-based units currently, and we're in preliminary stages with aquatic units. And our main sectors are in government, mining, construction, infrastructure, and infrastructure maintenance.
Awesome. And to round out this conversation, we have Captain Mike Leo, if you will provide a quick intro.
Good afternoon. My name is Mike Leo. I'm the program director for FDNY Robotics. We oversee the use of robotics and other emerging technologies for emergency response within New York City. We're currently utilizing drones, ground systems, and remotely operated marine vehicles at this time.
Awesome, great. All right. So based on the unique sectors that you each serve, I thought we'd start the conversation by discussing the current state of industrial safety and automation related to your organizations and work that's being done. So I'm going to have Grant kick us off, but what are existing risks that these technologies can help mitigate that are unique to the sectors that you serve and segments that you have insights into?
Yeah, it's a great question. Currently, one of our specializations is in the mining sector, and we help surveyors and engineers who sit at the edge of freshly blasted, unsupported ground in mines. And what they use right now for scanning perspective is essentially a LiDAR on a stick. And this can take a little of time, as well as put them very close to this unsupported ground, which is, of course, not particularly safe. Our technology allows them to launch a robot from anywhere from 30, 50, 100 yards away, get a scan, it's far more accurate because the robot's actually able to fly into the cavity in these unsafe areas, and then provide that data without people a safer environment to work in, as well as a lot less time that it would take them for doing these scans. And in the construction industry, our scans are Scans normally happen on a daily or more commonly a nightly basis, and in unfinished spaces close to the edges of building, and we're really able to take this repetitive task and move it from the human element, keep them away from the sides of the buildings, keep them away from any type of fall risk, and make it businesses a little bit more efficient.
That's great. And I think that that's a great feed in to understand a little bit more from Captain Leo about how they're integrating these systems in. So same question, Captain Leo, what are the existing risks that these technologies can help mitigate that are unique to the sectors that you serve?
Sure. So risk mitigation is everywhere in the fire department, obviously. We're using the drones are giving us a great overhead picture, depending on what type of sensors we have on. We can track the fire. We can see where the movement's going. We can track members on the roof. We can track our streams coming off tower ladders to make sure they're hitting their targets. They produce a lot of water inside of the building, which reduces risk and weight and collapse. Also, we're able to get a good overhead view of the building and kind of look for signs of collapse as well. Subterranean environments, we can also send ground robots down and kind of get a good view of what's going on down there, whether it's a train derailment or some other type of event. So basically, we see just from operations a whole lot of risk mitigation from the use of robotics.
And just a follow up to that, Mike, are you always looking for new technology to support the sort of the effectiveness and safety of your team?
Of course. So we always have our eye on the bleeding edge technology, but it's often we have to wait quite a while before it becomes reliable enough for us to trust it in a real use case type of scenario.
Oh yes, we talk about trust of these systems quite often. So Adam, I want to pass over to you and give you an opportunity to reflect on that same question. How are you seeing these technologies being used to mitigate risk?
Yeah, it's interesting. There's a lot of industries that we've had visibility into, and we've helped drive safety and efficiency into. I think a classic use case we can all understand is well. First off, let me just say that it turns out that the streaming sensors that are required to help with this are actually ubiquitous. I mean, there's 1 billion cameras that are deployed on the Earth right now. Lidar, of course, is becoming much more prevalent and low cost and super important. So that the sensors are actually there, but we're just at the cusp of being able to actually leverage it the way we should be. I think a lot of people can understand. We all drive around. We know that there's intersections and roadways can be a lot safer. We've seen a lot of incredible improvements in leveraging all the cameras that are looking at looking down at vehicular movement. We now have the ability with incredible granularity to understand interactions of vehicles, pedestrians, cyclists. We can give priority to emergency vehicles a lot more efficiently. UPS and FedEx trucks are now getting priority treatment in some ways. Curbside management. The adage is you can't manage what you can't measure, and we're now at the point where we have superpowers in terms of measuring the space. Like simple things like wrong way drivers. I mean, these are simple things that we should never have deaths occur because of that, but we still do, and we're really starting to see that change with these technologies. Even just simple things like anomalous activities. When a strange group of people converge and then disperse really quickly, we now have the ability to identify that and analyze it and identify, understand why did that happen and how do we mitigate it better. So I think we're at an incredible place where we now have, we literally have superhuman abilities with AI and computing and the likes of LiDAR and computer vision now.
I think the reach into all of these different sort of sectors is pretty fascinating. Grant, I was going to follow up with you, but we were having some connection issues, so I want to do so now. Some of what you were describing would require that these systems work without GPS. Can you talk about how that works?
Yeah, it's a great question. So working without GPS requires a SLAM algorithm. So what essentially needs to happen is the robot or any type of autonomous vehicle needs to be able to sense where it is in its own environment and then create maps off of that. So using its own autonomy and its own brain, whether it be internal or external, as some other units are, the robots really need to be able to operate in areas that are not all GPS, because as we know, there are a lot of areas that aren't, the GPS is just either weak in, cities as well as areas that are less densely populated, and at the same time indoors as well as underground. So being able to map while simultaneously being able to provide information back to a user is very important.
Thank you for that. So let's discuss a little bit more about future use cases. So we understand how it's currently being used in sort of all of these different spaces, but I think our audience would appreciate understanding the new technologies that are going to impact different sectors moving forward. So Adam, I want to start with you. I know NVIDIA has sort of a unique perspective on enabling technologies for autonomous systems. Can you tell us a bit about how AI and new autonomous technology is going to impact certain systems or operations in the future?
Sure. Yeah, I think that that almost every piece of important infrastructure we have, our spaces are going to increasingly leverage automation. And I heard the word robot a lot so far. I heard Grant and Leo both talk about it. And I think in our minds, when we think about robots, we have a vision of what we have this thing that's crawling across the floor. I think our buildings, our intersections, our airports, our manufacturing lines, they're all increasingly going to become not robots per se, but they're going to have levels of automation that are going to increase efficiency and safety without a doubt. I mean, we're seeing this, all over the place. We frankly, and I think as an industry, we've probably spent and if I'll pause on that for a second. If you think about a robot kind of does three things, really. It perceives the world. It reasons, it makes some reasoning, it makes some assumptions and understands what's going on. And then it takes action to improve an outcome somehow. I think we spent the last 5-ish years really perfecting perception, the level of understanding and being able to measure space. Where now the future is now heading us towards leveraging a lot of incredible technologies to do the reasoning and to take action. And so, we think about autonomous vehicles, ultra smart robots on wheels hurtling down the road at 100 miles an hour. We're going to leverage a lot of that capability for our buildings and making our workplaces a lot safer. I would also say it's interesting, and I meant to say this earlier, that I think COVID was an interesting moment in time for a lot of these industries where in a lot of buildings, we didn't, if a fire broke out on the 3rd floor, we actually didn't know how many people we needed to evacuate. We literally, in some cases, we had no idea. COVID actually really shone a spotlight on the importance of understanding interactions and how many people are here. What's the heat map? What is the density of people? It's actually been an interesting, it's been an interesting moment to sort of just shine a light on how important this is for us. And I think we're, at least with the adoption of some of these technologies, we've benefited from that.
Yeah, and Adam, I've been noticing as part of the COVID protocols too, certain stores are counting the number of people who are still in the store, so that they're controlling the amount of population and the amount of disease spread. But I look at it more from a safety perspective. If you're coming at it from Michael's side of the world, where you're trying to get as many people out as possible, having an accurate count of number of people, either A, still in the vicinity, or B, how many people used to be in it, so that you get an accurate count of people out, seems like it would be very important going forward.
Great.
So that's a great segue into how can we prevent fires using this technology? And Captain Leo, I'm going to let you jump in on that. How will mapping and drone technology, do you see it being used for that in the future?
Well, I think our GIS unit works hard every day on mapping and overlaying certain layers. I look at the future with connectivity, edge computing, and sharing data with other city agencies certainly fall into this category. where smart cities, where we can actually maybe put smart sensors into new buildings, and maybe it could be part of the new building code, where instead of just a regular camera, we would have other sensors as well. We would know, how many people were there. We would know the heat sensor, the temperatures of the floor. And we do some of this right now. So if we go into a high-rise building, we could possibly dongle into their security cameras and know that there's a smoke condition on the top floor. It's just a matter of technology getting a little further. And like I said, the connectivity to share this information with other city agencies is very useful. I spoke briefly with Adam and Grant last week about using mapping layers for smoke plumes, and New York City Department of Health overlaying it onto their GIS layer of people who have called for smoke inhalation or got an ambulance for smoke inhalation, and they can actually validate their cases by our layer as well to see where that smoke has hit. As far as predicting fires, I think that would take a lot of data, and but I do see that coming.
And I think also to talk about that, Michael, is looking at the digital twinning. So when we move towards the future, having full scans of either an entire building or an entire city, I think would definitely be helpful for you guys.
Absolutely, absolutely.
Are there ways, and Grant, Mike, you might both have thoughts on this, are there ways that organizations can track metrics for risk mitigation? I get that question often within different industries.
Yeah, it's a great question. One of the simpler ones for us is mining, and the metrics aren't terribly difficult, and it's time spent underground. The less time that a miner or a surveyor has to spend underground, the safer they are. So scans that used to take 8 to 12 hours, now with our technology can happen in about 5 to 10 minutes. And this removes a lot of danger from everyday lives. And with some of the technology that we recently launched with one of our partners, an automated mining vehicle drove into a newly blasted area, launched our vehicle. We received all the data and scans back from our vehicle. We then landed the vehicle, and all of that was done from the safety of from an above ground control center. So it's really the future is being able to remove people from these dangerous environments.
Mike, did you have anything to add on there from FDNY?
Yeah, so obviously the fire department collects lots of metrics for our use, but robotics is fairly new, and the drones are still very new. So we collect every metric we possibly can, but currently, we really don't have a great system to measure risk reduction in any way. We're trying to figure that out now, where we can take all the data that we have. Obviously, we use it for our own operations for risk reduction. So a lot of data we collect is for that, but not so much for firefighting cases. And
Michael, is that more for the safety of the firefighters, making sure that they're not putting themselves in any additional risk that wouldn't make a lot of sense?
So we try to track notable times when we had an impact as a unit to, for example, if some firefighters were to bail off of a roof, we know, we can see from the air that they were safe. I mean, obviously, this is a clear metric to say that, we did our job there, and it was important for us to be in the air. But as far as it's hard to get the metric for a regular fire of what we did. Occasionally, we'll find fire in pockets, from our thermal cameras. Basically, we'll send firefighters back to that location. And we do track all of this as much as we can. It's just, it's hard to get an overall sense of how much we have an effect on a regular fire.
Adam, I'm wondering, how do you see these technologies being used to predict future problems? And we talked about this a little bit last week, so I'm hoping that you can speak pretty heavily to it from a reliability and safety perspective.
Yeah, sure. I think one thing that I'm, that over the last, 6 to 7 years that we've been working on this, one thing that's so interesting, and I'm personally so excited about is you think about infrastructure, you think about even just what Michael was describing and Grant, and a lot of these sensors, a lot of this technology that we're deploying today is kind of frankly being bolted on. Like almost almost literally in some cases duct taped to the side of the building, to a street light, to a factory line. Where we're headed is extremely exciting, which is these sensors and this capability, the ability to instrument and to monitor and manage better is going to be built into our infrastructure from the beginning. So we're actually going to design to operate as opposed to operate and then bolt this stuff on. So this and that has a lot of implications. One of the interesting things, I think a lot of maybe people that are watching this have heard the term digital twin before. And that simply is just a fancy word for saying, if we can build something and model it and really study it before it physically is ever built, now we have a model of this thing, and then we build it, and we have a twin. We have a virtual operational simulation environment, and we have the thing. And so that concept, I think, is going to help us do an incredible amount. I mean, even just an autonomous vehicle, if you think about an autonomous vehicle, vehicles are being simulated to drive millions and millions and millions of miles through crazy scenarios, and we can simulate that. And then when we put it on the road, this vehicle has been through a PhD. It's been in like 30 years of university. I mean, it's a smart thing. That's, I think, where we're headed with a lot of the infrastructure. And so, yeah, I think the digital twins modeling, designed to operate, is going to be an incredibly impactful. It is a technology, but it's almost just it's a way of life. It's a mindset and a worldview for how we design our infrastructure. And I think it's going to have major societal impacts, benefit, it's going to benefit safety and efficiency.
And Adam, I think you mentioned it earlier, but the collection of data and the more data that we collect seems to be key to driving that future, right?
100%. This is yes, that was, almost an unspoken thing. You're 100% right. This is all based on data, on collecting data, and we have a lot of data now collected, and now we just need to put it to use. You're right.
One of the things that you mentioned previously was looking for those statistical anomalies, especially when you're looking at mitigating certain risks like leaks and fires, and so that all plays into that data usage. So.
It does. In fact, actually, just a really quick anecdote. I mean, a partner of ours had some security cameras to monitor university, campus. Primarily, it was like nighttime, monitoring and just making sure things were safe. And this safety technology was really to look for anomalies, strange things, people chasing each other, and weird, really weird things. And it was able to find a major water leak, and they were able to find it in real time and mitigate that problem immediately, and save the university, hundreds of thousands of dollars. And so that's, when I say that there's this overlap of efficiency and operational efficiency and safety, they're inexplicably intertwined to some way. If you have an efficiently running space, it's going to inherently be safe, I think.
All right, so I saved time here at the end to talk a little bit about implementation of these systems. So we have this great technology, but how are we getting these teams to train with it, to buy in? Mike, I thought you might launch us into this conversation because we had talked a little bit about the resistance to new technologies.
Sure. So the fire department is always a little resistant to new technologies. And in the very beginning of our program, we had somewhat of a problem with our incident commanders. And of course, there's a generation gap with technology. We basically, they really wanted no part of us or what we were doing. So eventually we kind of showed them what was going on. We put the tablet in front of them, kind of explained it to them. And then slowly it started to become like a mainstream use. And then we slowly integrated into training, drills, exercises, anything we did. And now I will say, like, when we show up, they're looking for it because it brings so much value to what we do. And I think, transparency, both inside the department and outside the department is paramount for what you're going to do, because we need to gain trust and we need to retain trust. And that's the way we did it.
Grant, do you have anything to add on to that? Because I know that your organization works with all these different industries on adoption of the technology.
Yeah, and what Michael was saying is pretty correct. I think as human beings, we're all a little reticent towards change. So getting people to adopt the technology is difficult at first, and I think that we're just getting through that first wave where the early adopters have kind of proved out a lot of the different technologies, and it's becoming more and more mainstream and becoming standardized amongst both from a national perspective as well as an intercontinental perspective, where a lot of the same technologies are being used by people all over the world. And the more and more adoption that we can get, the more it creates a standard where people are just adopting this technology when they're first starting out, either at a construction site or in a mining or just inspecting legacy infrastructure. So if you're going to go out there and continue to do this inspection on a daily and weekly basis, having this technology at the forefront would really increase your efficiency and take you out of harm's way. So it just makes everybody's life easier the higher the adoption rate gets.
All right, we have a few minutes left, so I want to give everyone sort of a last word. So any additional thoughts from your organization or what you're doing, or even maybe a call to action related to these technologies and the sectors that you serve? Let's start with Adam.
Well, I would say that I guess a few statements would be these solutions are production ready. This is not a science experiment anymore. We've seen worldwide deployment. As Grant mentioned, I think also an important aspect too is costs. Costs are actually coming down significantly, and I think that helps adoption. I think when anything starts out, it's going to be expensive because in some cases you haven't optimized everything in your production, your software, your hardware. I think we're at a point right now where we have critical mass of solutions. We have a critical mass of really incredible development efforts, optimized solutions, and just that translates into cost. And so I think that's maybe my statement. It's production ready and it's ready to go.
Cost is a major concern for organizations, so that's reassuring. Captain Leo.
Sure. We're in exciting times. Technology is moving very quickly. As to feed on what Adam was saying, reliability, right? So reliability is there. We can use it, and it's great to see technology used in emergency response and us being able to utilize it to help people.
And Grant.
Yeah, I guess I'll echo what these guys are saying and just say that the technology is there, but we're always interested in pushing the frontiers forward and making sure that we are discovering new abilities for what it is that we can do. There's use cases out there that nobody here has thought of, and the more that we hear back from the industries and the more that we hear back from our communities, the better off I think that we're all going to be.
I'm an advocate of that. I love the opportunities to learn from others and look for those use cases that can be implemented elsewhere. It's exciting to see more and more organizations and industries adopting these technologies. I believe it's going to be a game changer for workplace safety, for efficiency, and for improved operations. I want to thank you all so much for participating today. We hope that you found the discussion valuable. And I will speak for the panelists and myself and say that we'd be happy to connect with any of you if you have questions or wish to discuss further. With that, thank you to Velodyne Lidar for hosting today's World Safety Summit. And Charlie, thank you.
Hey, Keely, it's great to see you. And thanks for logging in from the East Coast in the afternoons as you have out there. And also all the great panelists. Once again, it's so important as we talk about safety in terms of beyond the vehicles and the robotics and the different things that you guys were discussing. So we look forward to following up with you on that. So have a great afternoon. Thanks again, Keely.